Algorithms. Let us see what is an algorithm, when to use an algorithm, and how can you design an algorithm. Let us first see what is an algorithm. An algorithm, it is a procedure that is used for solving a problem. You can see it like this. Whenever you have a problem or a task in hand, what are the exact set of step-by-step instructions to be followed so that this task can be completed? This list of instructions, this is called as algorithms. You can understand it like this. That is, if you have a computer, this computer is ready to do whatever task you may want it to do. But the problem is, it does not have the brain to think and come about on how to solve this problem. That you have to explicitly tell it that these are the steps to be followed. Do it like this, then you will be able to complete this task. So how do you explain to the computer how to do this task? This is what algorithm is. The next question will be, how can you design an algorithm? What are the prerequisites that you should have? So the first thing, as we already know, is that you should be very clear about the problem description. What exactly is the requirement? What is your task? What is the input? What is the output? Next thing is, you should know about the constraints of the problem. Constraint means whenever you want to do a task, there may be certain rules. That is, you can't follow these particular paths in order to solve, or maybe that you want to solve it inside this particular time. These things are constraints. So whenever you have an algorithm, you should make sure, whenever you are writing an algorithm, you should make sure that you are always following these constraints while designing it. The next thing is that you should know what input, what is the output. Whenever you have any particular input, what will be the output? If you know this, then only you can design the exact steps in order to reach this particular output. And then you should know how to solve this. So you can see it like this. You have an input. This is your input. Then you have your output somewhere here. How can you reach from this input to this output? For this, you may have to do a step 1. Then you may have to follow step 2. So each of these steps, these are some operations. Okay. Then step 3. So you will take this input, apply step 1 on it. Then on that output of step 1, you will apply step 2, then step 3, then step 4, and so on. And finally, you will reach the output. So these steps, what exactly are to be done here? This is what is your algorithm. Now let us see, how can you design an algorithm? What should be your thought process while you are designing an algorithm? You can understand it like this. You have a kid. So you want to teach this kid how to do some particular task. Think of it like a video game. You have a video game, a bike racing video game. You want to teach this kid how to play this game. Think that this kid is playing this for the first time, and you want to make sure that the kid will be able to play this game on his own. How will you explain this to a kid? You will say him that whenever you see the start signal, what should you do? You should press the up arrow so that the bike will accelerate. You keep on accelerating, and whenever, let us say, you see a turn or you see an obstruction in front, you want to decrease the speed. What should you do? You should no more press this acceleration button. You should release this up arrow so that it will decelerate. What if you want to brake? If you want to stop your bike or you want to decelerate abruptly, you should press the down arrow. This is how you are going to explain to the kid, right? These are the step-by-step instructions. If you see a turn, maybe turning left, then you should use the left arrow. Similarly, if there is a turn that is turning right, you should use the right arrow. So these are the exact instructions which will help the kid to play on his own. Now you know how to play. You are teaching him how exactly can he play. Then maybe you will explain him that you are riding the bike right now. In front you saw some other bike or maybe a car or something. How will you move aside? You have to see both the sides. If there is some space on the right, then slightly press the right arrow and continue racing. or if there is some space on the left, then you can slightly plus the left arrow, then move slightly towards left and continue racing. So these are the different things you will explain, how to face each of the obstructions in the road, how can you reach till the final point. This set of instructions, the step-by-step instructions you are giving the child, this is the algorithm. If child is the computer, then these steps that you are explaining to the child, these are the steps in your algorithm. This is how you should understand. That is, you should be clear that computer is capable of doing anything for you, but the only problem it is facing is that it don't know what are the steps to be followed. This is where you have to help the computer. That is what is algorithms. Next thing is, what are the different types of algorithms? There are many algorithms. In the lecture series, we'll go through all of those in detail. Here we are just having an introduction. What are the different types of algorithms? First thing we always think about is brute force algorithm. What is a brute force algorithm? This you can think of the simplest approach, or you can say first approach that you see, or the naive approach. This is what you call as brute force. If you get a task, simply in the first thought itself, what is the basic approach or the steps that you're coming to your mind? That is what we generally call as a brute force algorithm. Next thing is, there are something called as recursive algorithms. What is the speciality of recursive algorithms? Whenever you have a problem, let us say a larger problem, in a recursive algorithm, you are going to break this into several subparts. That is, this problem will be broken into many subparts. Now, each of these subpart will be solved by the same recursive problem, and then again all these will be used. It will all come back together to give the final solution. This is how a recursive problem works. So here you can think of it like this. You have the main problem. In order to solve that, you will call a subproblem with the same function. In order to solve this, you will call another subproblem again with the same function. Again, you will call a subproblem. Then let us say at this point you got the output for the small subproblem. You will give it back to the larger subproblem. Now it got the final solution for this larger problem. It again propagates forward. At this point you have the main solution. This is a recursive approach. Another common approach is backtracking. What is a backtracking algorithm? In a backtracking algorithm, you'll start from the input, then you'll keep traversing till you reach an output. Sometimes you may understand that, okay, you hit a roadblock, you can't go forward, then you will backtrack, come back and then choose another path. This is called as backtracking algorithm. Next thing is, a very common one is searching algorithms. Whenever, let us say, you want to search for some value or something, could be in an array, linked list, whatever, these are called as searching algorithms. Similarly, you have something called as sorting algorithms. This is when you have a lot of numbers, alphabets or something. You want to sort those in an order, that is ascending order or descending order. This is where you use sorting algorithms. Then you have hashing algorithms. Hashing is, it is kind of searching, but the difference with hashing is, here you have key value pairs. Every single entry will be a key value pair. Now, if you want to find the value corresponding to any particular key, you will do a search in the hash table. You will search for the key, find out what value it is pointing to, then you will find this value. This is hashing algorithm. Then there are certain approaches. One is divide and conquer. This is a very popular approach for solving some problems. In this, what you do is, you have a larger problem and you don't know how to solve this, or maybe it is difficult for you to solve this. What will you do? You will divide this into smaller problems. You will conquer each of the small problem alone, and then you will merge all these together in order to find the solution for the main problem. This is called as divide and conquer. So when I'm explaining all these things, keep in mind that in the coming lectures, we are going to do a deep dive into all these. We'll learn exactly what each those are, and we'll see a lot of examples. Here we are just having an overview, okay? Then other than divide and conquer, what else do you have? You have greedy approach. What is a greedy algorithm? Let us say greedy algorithm. As the name suggests, at each step, let us say step 1, step 2, step 3 and so on, each step you are going to just consider what is the best approach at this point. You are not concerned about the final output. At each step, you will just see what is best at this point to do and you will do that. This is called greedy approach. So it cannot be applied to all the problems. There are certain problems which can be solved using greedy approach. That is where you will apply the greedy algorithm. Then another algorithm is dynamic programming. You have dynamic programming. What is done in dynamic programming? Here again you are going to divide the larger problem into smaller problems. But the difference with divide and conquer is, in case of dynamic programming, the smaller problems, they will have overlapping subproblems. Let us say these subproblems here and these subproblems here are similar or overlapping. In this case, you actually don't have to solve all these things. Instead, if you store the results of each of these subproblems, you can directly use it here. So when it is growing exponentially, that would mean at many positions you can use the same solved solution. This is where dynamic programming comes handy. You will be able to save your solved solutions and use it in the overlapping subproblems. So as of now, you just need a very basic idea. As we dive through, then you will be clear of what all these things are. In this lecture series, we'll go through each of these things in detail. Then you will be very clear on what these approaches are, how to handle those. One more thing, that is, if you are new to algorithms, I would really suggest that you first learn data structures before learning algorithms. You can see the data structure lecture series that we have. You can go to the data structures playlist. The reason I'm saying this is, once you learn data structures, you'll know how to store data. In order to write an algorithm, the basic thing you need is you should be taking data from some storage, doing some transformations. Maybe you will use some other storage mechanisms, and finally you will reach the final answer. So if your data storage is not right, there is no way you can design the right algorithm. Because of this, I would really appreciate if you would learn data structures first, and once you're clear with data structures, you come to algorithms. Otherwise, if you already have basic idea of data structures, then it's okay. You can continue with algorithms, and along with that, whenever you get confused somewhere, you can go to the data structures lecture series. You can understand that and then come back. Okay. So in the coming lectures, we'll see different types of algorithms. How can you solve those, and what is the mindset you should have to solve those problems.